In this video we're going to talk about Syslog and tracing. So Syslog, as you might know, is a standard way of logging data into a device. So this is a way that Juniper uses based on the way that FreeBSD uses Syslog. So this way the system will log every single event that occurs on the device. So this might go from anything such as an interface going down to a OSPF, flap, anything of that nature, an internal process of how the system works. So we'll see that in a little bit. We'll see a log file. We'll see some way of actually helping us understand what the log file messages present. So we'll see that in a little bit on a router. The other topic we're going to talk about is tracing. So tracing is a way that the system gives us to troubleshoot something that doesn't have an obvious root cause. For example, after you do any configuration, you have shell commands that allow you to verify that everything is operating as it should. But you might encounter sometimes issues where you don't have enough information using shell commands. The example I'm going to be using in this video is going to be, imagine you have two routers and they're speaking OSPF between each other. But for some reason you look at the configuration looks fine, but the adjacency does not come up. And looking at the configuration, you can't see why. So maybe there's an underlying issue you are not seeing. Maybe you have a configuration problem. Maybe you have a firewall filter. Maybe you might even have a bug. So you could do trace options, which, if you come from the Cisco world, are equivalent to a debug, and get more information on what's actually going on. Information you wouldn't get using a shell command. You might get specific adjacency information. You might get specific hello information. Deeper, more verbose information of actually what the OSPF process is doing in each one of the routers. And with this information, you can further troubleshoot and hopefully resolve your problem. So we'll see that in a little bit. So first off, let's see the Syslog. So it's good to understand that Syslog has different severity levels predefined. So these severity levels basically are a way of classifying a particular event, how that particular event is ranked in importance. So they go from 0 to 7, and for example, at level 7 we begin with debug, which are basically debug level messages. So these are useful information for developers debugging the application, not so much for operations, unless, like I mentioned before, you want this amount of information because you're having a particular issue that you can't see what's the root cause any other way. So, for example, when people encounter bugs, they typically require to send debug information to the vendor, to Juniper or Cisco or whoever actually coded that software. The next level would be level 6, which is informational. So basically informational messages, normal operational messages. They might be for reporting or throughput. Typically they do not require an action. Next level is notice. Typically that means normal but significant issues or significant condition. You think about something that might be unusual but it's not an error. That type of thing. And as we go down the line, we have warning, error, critical, alert, and the last one is emergency. So basically their conditions are, the further you go down, the more critical and the more impacting to the system they can be. So you might go from something like an interface flapping, or losing a neighbor in OSPF, or losing a neighbor in BGP, to something like you have an unresponsive line card, or you have an unresponsive port, or something that threatens the actual stability of the device, or a kernel issue, or something of that nature. So the idea here is that we can configure Syslog to report whatever we want. We can configure Syslog to report all the debug messages on the device, which will in turn result in a very chatty log, in very big logs, because we are debugging trivial things. Or we can adjust it to only give us very critical, very error or very alert type of information. It's really up to us. So we're gonna see how here on R1, we're gonna see a little bit about what's the default configuration that the system has and how we can actually tweak it. And we'll open a couple of log files, and we'll see how we can read them better, and we'll see how we can get more help from the system. So let's go ahead. I'm here on R1. I'll do show configuration system. And besides the users that this device has, we can see here that under Syslog, we have different configuration, which is default. So basically, the return is for any user, we're going to show any message that classifies as an emergency. So the most critical level, this will be level 0. So basically, a panic condition that will affect the stability of the device. Basically, saying you need to take action and you need to see why this is happening and fix it as soon as possible. The main file that we have on the device is called the messages file. And as you can see, it will show for any type of event, it will log into notice level. So notice level, it's typically level 5. It typically means normal but significant condition. So something that might be unusual and might or might not require attention. And for anything related to authorization, it will be an informational level, so it will be a normal operational type messages. And then we have another file which is called interactive commands, which will log commands put into the router at basically any level. So that's the default configuration on the device. We could change it, and another thing that we typically do is, besides telling the device to store these logs locally on a file, we will typically recommend, and it's the practice that you would see most in large enterprises or even medium enterprise, any enterprise where you have a relatively significant number of devices, so anything about 20, 30, or anything that's quite critical. You would log, besides logging in the actual device, you will log into remote servers. You will log into distributed Syslog servers. That way, if the device fails or if something goes on with the device, you can actually check those servers and you can determine, or at least gives you some more information, sort of a black box type of thing. It gives you more information about actually what went down. Because let's say that we are here R1, and R1 suddenly stops responding. And we are left without, did we have an issue with the actual hardware there, or did we have an external event go on? For example, a power issue. If it was a power issue, unless this device had multiple power supplies, you wouldn't see it much on the Syslog because the device is working normally and suddenly it doesn't have any power. If you have multiple power supplies, then you might see a Syslog message of one of them saying, "Oh, I lost my input feeds," or something of that nature. And if the device actually had a hardware issue or something like that that caused it to reload, or a memory issue or something of that nature, typically it creates Syslog messages, at least one or two before it crashes and reloads, or crashes and stays unavailable. So it gives us more information to do our investigation later on. So that's typically recommended. So let's go into configuration mode and let's see what we can actually take a peek at the different options we could do under system Syslog. So we do set and the context sensitive help, and we can see that there's several options, console logging files. If we want to create more files for specific things, we can tweak the default to tell it, no, I want more, I want you to start logging not on severity notice, or I want you to log a debug, or I want you to log a critical. We can play with that. And we can, as you can see, we can set a host that we would send the Syslog file from the device to that particular server or a particular group of servers. Because you might do that, you might have servers in different cities or in different buildings or something like that, to make sure that in case of an event, you have where to start your investigation. So let's get out of configuration mode and let's take a peek at some of the logs. So the main log is messages, and basically most of the events in the systems are logged here. And you can see that it's quite long. I have the spacebar pushed, and you can see that it just keeps going on and on and on. So typically an interesting way, or a good way of reading the log files, because typically you are looking for something, you are searching for a particular thing, or you just want to see unusual things. You could play with the pipe, and you could play with different commands here. You could, for example, use last and say, I want to see the last 10 messages only, and it will only print that. So maybe you don't want to see this device has a log file that stretches, since 2 months or 3 months. You don't want to see what happened 3 months ago. You just want to see the last 10 messages. You could do that. Or you could use things like match, which allows you to use regular expression to search for a particular thing. So let's say that I want to look for MGD, which is the process that handles things like commit. We could check that and only see that. Or let's say that we want to see anything except MGD. So we want to see anything else on the log, but we have a lot of entries from MGD, so we don't want to see that. So we could do it as well. So it's a very flexible way of actually looking at this. So let's look at, for example, the interactive commands log file. So we'll basically get here every single command that we have typed, and we'll get one. Whenever we did a commit, and as you can see, it's a very long file as well. So we could do the same thing. For example, we could say match lab. It will give us the different commands that the lab user has done. And we see another thing we see interesting is if you're reading these logs, it might have some interesting lines, but you might not be too sure what, for example, let's pick one of these. For example, well, that's kind of self-explanatory, but let's pick that one anyway. UI login event means. So you can actually consult the help on the system. It will give you more information about what the particular code means. So if you do help Syslog and you copy that, it will give you detailed information about what that means. Well, not super detailed, but it will give you more than, for example, the context-sensitive could. So it's given us here what's the code or the name. It's given us what the format is. It's given us some help. It means that a user started a CLI session. It gives us some description. It gives us that it's an event type of message, that it's not an error, and it gives what the severity of that message is. So very interesting, very powerful in the sense that you might be working in a branch office, or might be working in a remote site where you don't have particular good connectivity, or you might not even have any connectivity to the outside. So using the help of the system, you can actually get what that message means without having to go into Google or anything to search for it, or without having any manuals for the devices. Very interesting. So now let's talk a little bit about tracing. So like I mentioned before, tracing means getting more information, getting more verbose information regarding a particular process or a particular issue that you might be trying to fix. So if you come from the sysquirrel, it's equivalent of a debug. So it's a way of getting information that you wouldn't get using show commands. So let's do an example. For example, I have here, we could do it under one of the interfaces and shut down that interface and see what message we get from it. So let's go ahead and do that. Let's go into configuration mode. My management interface was EM5. Now go set interfaces, EM5, trace options. Let's use a context-sensitive help. It will ask us for flags. So basically flags are different things you can enable. So think of OSPF. If it's OSPF, we could tell it, I want to have events, or I want to have packets, or different options that better suit what you are trying to actually fix, or what you are trying to actually get from the system. So in this case, we have 4 different options. We have all, we have event, we have IPC, we have media. So event, it will be anything that happens on the interface. IPC will typically be messages between, or issues between the actual device and the port. And media will be media changes. So just for simplicity, I'm going to use all. and I can't add anything else, those flags or those options will differ according to where you're enabling your trace options. If you're doing it on the routing protocol, it will give you more options related to the routing protocol. As you can see here, my options are related to the interface. And another thing that's quite interesting about tracing on Juniper devices is that most of the trace options are actually safe to do under production, which is not the case, for example, in doing debugs in Cisco, where a debug in Cisco can make the system unstable and actually crash it. Here, that typically is not the case. You can specify, you can tell the system, I want you to create, for example, 10 files with this particular name or with this particular syntax, and those 10 files can be bigger than, let's say, 1 meg or 100K or whatever amount you specify. So it's more safe, and it's actually, you can enable it on production devices and typically won't have any negative impact, and it will allow you to troubleshoot the issue you're trying to fix. So I enable the trace options. I can see it if I do show compare. So let's do commit and quit. And now the question is, since I didn't have the option of specifying where that information would go, so where is the information going? So the information going, in this case, is going to a log file called DCD, which is a log file for the process that handles the interfaces in Juniper, which is called the device control daemon. So I could actually see it if I do show log DCD. I will see some information there. I can see that the log was clear a little while ago. So fantastic. So now if something happens with the interface, for example, that it goes down, it's deactivated or anything like that, we should see an entry there, since we enable trace options on the interface. So let's do that. So it would happen that when the event occurs, that information would be recorded on that file, and I would have to do show log whatever and see it. An option that I have is to tell the system, keep monitoring that file, and whenever something comes up, show it to me on the console. So I would do that with monitor start and the name of the file. So let's do that so we can see it. So we'll do monitor start DCD, and let's go into configuration mode and let's deactivate that interface. So inactive, yes. Let's do commit and quit. So we went into configuration mode, we deactivated the interface, so that means the interface will be admin shut down or admin down, and now after that's committed, so that will write into that file, and we'll see it on the output there, and we can see it there. We're seeing some information in that log file that's related to the trace options. So let's imagine this. Imagine you're working on a device, or you got an alarm for the device, and the device has some failure that doesn't allow you to, or you are actually logging to the device, but you're seeing the same file. You're seeing the same file, or you're seeing the same output over and over and over again. Maybe you have a critical failure in the device, and it's giving you this super annoying output, line by line. You're trying to work out, you're trying to see the output of shows. So how would you be able to remove that, at least for a little while you try to fix the issue? You would use a keyboard combination that's escape Q. So if you do escape Q, which I just did, you will see this message. You would see monitor and syslog output disabled. Press escape Q to enable. So now if I go ahead and I unshut the interface, I won't see that information. I won't see what we saw here. I won't see the output again from the DCD file that we're seeing here. I just won't. I would have to go and do show log DCD again to be able to see any new output, or DCD, or if I'm doing any trace options or something else, whatever file I specified before. So let's say that I want to clear that particular file because you did a round of tests and now you have some output. You want to make sure you get a new and fresh information. You would use the command clear log and the name of the log, which is, in our case, it's DCD. And if you console the log again, or, well, we have we have the output disabled, so we won't see anything. We can see that it will only have one line saying log file clear. Well, we also got a message there. If I want to delete that particular file, I will use file delete. So file delete and the complete path, which is /log dcd. So to sum up, we talked about a little bit about Syslog, the different severity levels, what's the default configuration on our device, what the typical real-world recommendations are, and we talk about tracing, which is, as I mentioned before, it's the equivalent of debug and allows you to get more verbose information about a particular issue and to troubleshooting. We also saw how interesting it is to use monitor start and the combination of escape queue to provide or to disable that output on the console. Thank you.